So let's see what is Lagrange mean value theorem. Okay. Let F closed interval a b to R be a function where a b belongs to R and a is still less than B. If F satisfies the following conditions, what is first condition? F is continuous on closed interval a b. F is differentiable on open interval a b. Okay. Then there exists then there exists T belongs to open interval a b. It means C in between A and B such that FB minus FA upon B minus A is equal to F dash at C. Okay. So let's prove it. Prove. So define phi x is equal to x plus A times where A is a constant. Then phi closed interval a b to R is a function satisfying number one phi is continuous on closed interval a b. Second one, phi is differentiable on open interval a b. Okay, because f is continuous, we are assuming that f is continuous and differentiable. F is continuous on closed interval AB and differentiable on open interval AB. So because we are taking just constant summation of f with constant multiple of x and we are adding phi is defined in such a way, that is why phi is continuous as well as differentiable on open interval AB. Okay. Now we need to find a such that third condition of Rolle's theorem is also clarified. And third, phi A is equal to phi. We need to choose A in such a way that phi A becomes equal to phi B. We need to find A in such a way. So how we will find A? So you put phi A is equal to phi B. We need to find A. Okay, this is f A plus this is A f B plus A B. So solve it. What you got? Okay. So you got A is equal to minus f B minus f A upon B minus C. Okay. So let's take this equation. Now phi satisfies all the conditions of Rolle's theorem on closed interval AB. Then by Rolle's theorem, there exists C belongs to open interval AB. It means such that phi dash at B is equal to 0. It means what is the derivative of phi? So what will be this? F dash C plus A is equal to 0. Because phi is nothing but fx plus AX. So this implies what is derivative phi dash f, which is f dash f plus A. So when we will put value of C here, what we'll get? We'll get this one. So this implies minus A is equal to f dash C. So let's start. So from 1 and 2, what we have? From 1 and 2, we have FB minus FA upon B minus A is equal to f dash C. So Rolle's theorem is proven. Sorry, Lagrange mean value theorem is proven. Okay. So what is the physical interpretation of Lagrange mean value theorem? So we have A here and we have U here. Some function is there to there. So what is this point? This point is nothing but A F A. And this point is nothing but B F B. So Lagrange theorem says the chord joining these 2 points. What is the chord joining these 2 points? These 2 points. The chord joining these 2 points is nothing but so this is the curve, okay, and this is the F point, and this is B F B point. So the chord joining between these points is the chord joining these 2 points A and B. Sorry, I am saying this B and C point, or you can say P and Q. This is P point and this is Q point. The chord joining P and Q is, so P point is nothing but A F A and Q point is nothing but B F P. Okay. So equation of PQ, what is the equation of PQ? Equation of line joining PQ. It means a chord PQ. Equation of chord PQ, what is that? It is nothing but FB minus FA. The slope of PQ, what is that? Slope of PQ, what is that? Slope of PQ is FB minus FB minus FA upon B minus A. This is the slope of PQ. That is nothing but equal to the slope of tangent at some point C. Let's say this is the point C. Okay. Or you can say, this is the point C here. So this chord is parallel to this. This and this both are parallel. This is F dash C. Okay. Or C is in this range. So there will be some point C here at which the slope of the tangent to the curve is parallel to this chord. Okay. It means this tangent, the tangent of curve at C, that is having slope F dash C. So this tangent is parallel to this chord. Okay. This is the meaning of mean value theorem. Okay. So this is equal to F dash C. So this is the physical interpretation of Lagrange's mean value theorem. Okay. So today's lecture also this. If you have any problem related to this, you can comment on my YouTube channel. Like, share, comment, and subscribe my channel. So thank you very much for today's lecture. Thank you.